All right, so today we're taking notes on exponential growth, exponential decay, and exponential regression. So the first thing we're going to look at is exponential growth. Remember, for exponential growth, our b value is greater than 1. So exponential growth happens when our b value is greater than 1. In this problem right here, our initial value, remember, this is your y-intercept. So right here is where our y-intercept is. So our initial value is 30. Our b value is how much it's changing by every single time. And based on this graph here at 1, this graph is going 30, 60, 90, 120. So because this is counting by 30s, this is 180 and this is 240. So because our table here would be 0, 30, 160, 2, 120, what we can notice is we're multiplying by 2 every single time. So therefore, our b value is 2. Because our b value is greater than 1, this is considered growth, and this is increasing. Our r value is when we take b minus 1. So in this case, it is 2 minus 1, which is 1, or 100%. So it's growing by 100% each time. Our equation is f of x equals ab to the power of x. So f of x equals 30, 2 to the power of x. So looking at problem number 2, it says your hourly wage of $11 is increased by 3% every single year. So your initial value is that 11. Your b value, because this is increasing, you're taking your initial value and you are increasing it by 3%. So this 3% growth is really 1 plus r. And again, r is our rate here. So this is 1 plus 0.03, which equals 1.03. So our equation, remember, f of x equals ab to the power of x. So f of x equals my a value, which is 11. My b value, which is 1.03. And that's all to the power of x. Because this is increasing, remember this is growth and it's increasing. Remember to find your rate, that's that 3% or 0.03. So we would use the r value in this case to find our b. Here we were given our b value, so we have to use it to find r. What would your hourly wage be after 3 years? So you could use your formula again, which is f of x equals 11 times 1.03 to the power of x. But in this case, your x value is 3. So we're going to change this to 3. So when you plug this in, it roughly gets $12.02. Exponential decay is going to work similarly. The only difference is instead of going up, it's going to go down. So our initial value still starts off with the same thing. We're looking for this y-intercept. Let me go ahead and do a different color than black because black's not working. So halfway between 27 and 21, that looks like it's going to be 24. So this is subtracting by threes each time. So this right down here would be 18. That would be 12. And this would be 6. So I'm going to need this point, 112 here in a minute. I'm also going to need this point right here, 2, 6. So my initial value is right here at 24. And because my b value starts at 24, goes down to 12, Oops, wrote that backwards because it's decay. My next value is 12. My initial value is 24. It's going down by a half every single time. This is decay. It's decreasing. My B value is, or my R value is 1 minus B. So 1 minus a half, which is just 0.5. So the rate of decrease is 50% each time. So the equation is f of x equals 24 times 0.5 to the power of x. So you could view this as there's a basketball tournament or some sort of tournament happening with 24 teams. After each round, it decreases by a half every single time. So half of 24 is 12, half of 12 is 6, half of 6 is 3, and keeps going down every single round. Question number 4, this is a very typical question that you would see on some sort of state test. And question number 4 says a $35,000 vehicle depreciates in value by 27% each year. So the initial value is how much the car starts at, which is 35,000. My B value, I already know this is decay and it's decreasing. So therefore, our B value is 27%, or our ratio, I'm sorry, our rate is 27%. So to convert that to a decimal, that's 0.27. To find B, 1 minus R. So 1 minus 0.27. So 773.73. Because remember, you're saying that it loses 27% each year. So that means it hangs on to 73% each year. So your equation is 35,000 times 0.73 to the power of x. And this is f of x equals this. What would be the value of the car after 2 years? Oops, there's supposed to be an equal sign there. You would take 35 times 0.73 to the power of 2. And that would, if you typed it into decimals, would give you roughly $18,651.50. So that means your car after 2 years, if it started at $35,000, your car after 2 years would be worth $18,651. So last part is using Desmos to write an exponential function. Of course, if we're given a table, the goal is for you to type it into the table. Once you type it into the table, we would do a regression. One thing with this regression that you do have to look into, remember we would type in y1 tilde a b x to the power of 1. But when you type this in, there's a particular part when you enter this data in, we need to make sure that we check log mode. And I'll show you that when we're working in the class. So you type the values into the table. It says write an exponential function that fits this data. So even though this starts off at 200, so that would be your normal A value, when you type this in and do the regression, it actually becomes y equals 200.1 because it's trying to fit the data. Your B value is 99, which makes sense because it's going down. So therefore, this B value should be less than 1. Predict how many millimeters of the element would be left after 450 days. So then you would type in this whole thing, 200.1, 0.99 to the power of 450. And roughly there would be 16.2 milligrams left. At what rate is the element decreasing by? So you would take 1 minus B to find your rate. So 1 minus 0.99, so 0.01, or 1%. So it's decreasing by 1%, which is something that happens a lot with radioactive material. It will decrease in radioactivity over time. And this is a very common type question that would show up with exponential functions, especially exponential decay. And that's our notes for exponential growth, exponential decay, and writing it in Desmos.